As the P&ID should consider the ease of monitoring different process parameters, it's also responsible for specifying the critical parameters. The instruments showing these parameters should consider adding alarms in order to warn the operator when any deviation occurs. Let's take the example of liquid level in a vessel. The pump draws liquid from the vessel. Now, what if the fluid level keeps on falling quickly? If the liquid level falls to a certain value, the pump would be subject to cavitation. That's why we are adding shutdown action to stop the pump when the level reaches low liquid level. What if there is too much flow entering the vessel and the level keeps on building up? This may lead to overflow in the vessel. That's why we shall need to stop the inlet flow in case the level reaches high liquid level. So we usually need to warn the operator earlier so that he knows if there is something wrong. This can give him a room to check out what's wrong, and he may solve this issue without the need to stop the pump and disturb the operation. That's why we are having high and low level alarms. These alarms would warn the operator before the level is too low or before the level is too high in case of overflow, so that he may take some action to solve this issue without the need to shut down the whole system. That's why the vessel is sized to accommodate a margin between low liquid level and low liquid level to be either a certain time, maybe 1 or 2 minutes, a margin between these level values. Or if the time criteria is enough, we shall consider a minimum available span for the level instrument, which means that the level transmitter range cannot accommodate a lower value. So this is within 100 to 200 millimeters. So one of these criteria shall prevail in this case. This is one example of using alarms. Alarms are also used in pressure and temperature or in flow measurements. It's of course better not to add alarms on all instruments, as this may cause a disturbance to the operator. Too many alarms may lead the operator to neglect lots of alarms. This is highly important to consider because neglecting some alarms which are critical may cause operational issues. That's why it's better to add the alarms that are necessary and critical. Otherwise, we won't need to add these alarms as this may cause disturbance. But anyway, alarms can be easily handled when the instrument is already available, as they can be implemented through the system logic and they don't need additional material purchases unless the existing device is a field device. And in this case, we shall need to buy a new transmitter in order to show the alarm.